Hello all, welcome to this video on Network Programming Lab. Today I'll be talking about Wireshark and we'll be seeing how to observe a TCP connection process inside Wireshark and look into some of its features. Let's begin by looking into what Wireshark is. Wireshark is a network packet analyzer. Now, a network packet analyzer presents captured packet data in as much detail as possible. You could think of a network packet tracer as a measuring device for examining what's happening inside a network cable, just like an electrician uses a voltmeter for examining what's happening inside an electric cable. In the past, such tools were either very expensive, proprietary, or both. However, with the advent of Wireshark, that has changed. It is available for free and is open source. It is also available for Unix and Windows. Now we'll look into some of the intended purposes of the same. Network administrators use it to troubleshoot network problems. Network security engineers use it to examine security problems. QA engineers use it to verify network applications. Developers use it to debug protocol implementation, and people use it to learn network protocol internals. Now you can get the latest copy of Wireshark from the corresponding website. Currently the stable version is 3.6.6 and this is the main interface for Wireshark, where we have a space to enter the capture filter. It also shows the interfaces connected to your system. Now we'll discuss all the options in the top bar here and look what each of it does. The view option controls the display of the captured data, including colorization of packets, zooming the font, showing a packet in a separate window, expanding and collapsing trees in packet details. Capture option allows you to start and stop captures and to edit the capture filters. Analyze contain items to manipulate display filters, enable or disable the dissection of protocols, configure user-specified decodes, and follow a TCP stream. Statistics contain items to display various statistic windows, including a summary of the packets that have been captured, display protocol hierarchy statistics, and much more. Help contains items to help the user, like some basic help, manual pages of various command line tools, online access to some of the web pages, etc. Now we look into one of the features of Wireshark, which is filters. Now this shows few of those filters with the filter name and the filter expression used. For example, in order to see the packets which are only TCP, we give the TCP filter expression as TCP. Now Wireshark has two types of filters, which are capture filters and display filters. Capture filters are used for filtering when capturing packets, and display filters are used for filtering which packets are displayed. Display filters allow you to concentrate on the packets you are interested in while hiding the currently uninteresting ones. They allow you to only display packets based on protocol, presence of a field, values of field, and a comparison between the fields. Now we'll look into some of the steps involved while you visit a website. Starting with the first step being directing the browser to the particular URL. The user types a URL, which is Uniform Resource Locator, in the browser or follows a link from an already opened page. URL usually starts with HTTP or HTTPS. This is a signal to the browser that it needs to use HTTP or HTTPS to fetch the document for that URL. Second step is to browser to check on the IP. We enter the URLs into the browsers. These domain names map to IP addresses, which are the true location of domain's computers. This is handled by the DNS. Browser uses a DNS resolver to map the domain to an IP address. Now the third step is browser sending an HTTP request. A sample is given here. So it starts with GET, which is the method for requesting data from the server, followed by the path. Now the host computer stores the content of the entire website. So the browser needs to be specific about which page to load. That's why you are mentioning the path here. The final part is where you mention the protocol and the version. Now the second line below it specifies the domain of the requested URL. Now this is helpful in case a host computer stores the content for multiple websites. Fourth step is the host sending back HTTP response. For the same, we have another sample, so which begins with the protocol and version, followed by the HTTP status code. Here it's 200, which means there was a successful retrieval of the document, followed by a string mentioning the same, which is OK. The next part is called the headers. They give the browser additional details about the content, which are the content type, character set, and content length. Now, content length is the length of the document in bytes. Finally, the HTTP response writes out the actual document requested. This page is a simple HTML file. And the fifth step being the browser rendering the response. Browser has now all the information it needs to render the document that was requested. Now we'll look into the TCP connection process involved here. This is a TCP segment structure. Now the flags we are interested in here are FIN, SYNC, and acknowledge. Talking about TCP or Transmission Control Protocol, it provides a secure and reliable connection between two devices using the three-way handshake process. It uses the full duplex connection to synchronize, which is SYN, and acknowledge ACK each other on both sides. We'll begin with the connection establishment process, which is explained here. To begin with, when the client wants to connect to the server, it sends the message to the server by setting the SYNC flag as 1. The message carries some additional information like the sequence number. The acknowledge is set to 0. Maximum segment size and window size are also set. The server acknowledges the client request by setting the acknowledgement flag to 1. Acknowledge indicates the response of the segment it received, and SYNC indicates with what sequence number it will start the segment. For example, if the client has sent the SYNC with sequence number 500, then the server will send the acknowledgement using the number 501. Server will send the SYNC flag set to 1 and thus to the client if the server also wants to establish the connection. Sequence number used for SYNC will be different from the client's SYNC. Server also advertises its window size and maximum segment size to the client. Now the client sends the acknowledgement to the server after receiving the synchronization from the server. After getting the acknowledgement from the client, the connection is established between the two. Now data can be transmitted between the client and the server side. After transmission of data, connection termination takes place. Now for this, first the client requests the server to terminate the established connection by sending FIN. After receiving this, the server sends back FIN and acknowledge request to the client. After receiving the FIN and acknowledge from the server, client confirms it by sending an acknowledgement to the server. Now we'll look into another feature of Wireshark, which is flow graphs. Now flow graph show connection between hosts. It displays the packet time, direction, ports and comments for each captured connection. You can filter all connections by ICMP flows, ICMP version 6 flows, and TCP flows. It is used for showing multiple different topics. Based on it, it offers different controls. Now this is an example for the same. This is a TCP flow. You have the time elapsed here and the IP addresses of all the devices involved, and it also tells you the direction of communication along with what is communicated. You can also export it to an external file. Next feature is statistics. Now the statistics range from general information about the loaded capture file to statistics about specific protocols. We have general statistics, which consist of capture file properties about the capture file, protocol hierarchy of captured packets, conversations, that is the traffic between specific IP addresses, endpoints, that is traffic to and from IP addresses, and IO graphs visualizing the number of packets or similar in time. We also have protocol specific statistics like the service response time between request and response of some protocols. Next is protocol hierarchies. Now this is a tree of all the protocols in the capture. Each row contains the statistical values of one protocol. This is shown in the figure here. Two of the columns, which is person packets and person bytes, serve double duty as bar graphs. If the display filter is set, it will be shown at the bottom. Now looking into the columns here, protocol is the protocol's name, packets for the total number of packets that contain this protocol, bytes for the total number of bytes of this protocol, bits per second for the bandwidth of this protocol relative to the capture time, end packets for the absolute number of packets of this protocol where it was the highest protocol in the stack when it was last dissected. Packets usually contain multiple protocols. As a result, more than one protocol will be counted for each packet. Now we'll look into the two cases we'll be seeing here. First case is we capture the packets while browsing a website and we investigate the protocols in each packet, values of the header fields and its size. The second case being observing a three-way handshake connection establishment, termination and data transfer using TCP for the same. Now this is the main interface of Wireshark and we'll capture the packets. So we have space where we need to enter the capture filter. All these listed here are the interfaces connected to my device. Now, so I'll be tracking the Wi-Fi interface. I'll double click on it and go to the browser. So I'm choosing the website www.google.com. I type in the page Wikipedia. And click on the corresponding link. I choose the language and I click on another link which is Chess Olympiad and I come back to Wireshark and stop the traffic. Here you can see on top which is given as green, I have given TCP. Now that was a filter I entered. So which means all the packets which will be listed here will contain the TCP protocol alone. Now in order to see the others, I need to remove the filter. So it will take all the protocols in. Now I am to find out the three packets involved in a TCP three-way handshake, which is TCP sync, sync acknowledge and acknowledge. So I have taken the sync packet then sync and acknowledge, and the rest being the acknowledge packets. Now we also have certain other cases which is highlighted in black, like spurious retransmission, duplicate acknowledge, etc. that happens. TCP retransmission, duplicate acknowledgement again. We saw fin flag also for the connection termination. We need fin acknowledge and acknowledge for that. When you have a reset case, then previous segment not captured, retransmission, duplicate acknowledgement, etc. Now we'll look into these details here. The frame details which contain the Ethernet 2 section, IPv4 and TCP. Now coming into Ethernet 2 section, we will see that the destination here is the default gateway's MAC address, which can be verified using ipconfig/all. And the source is our device. This is the MAC address of my device. So I can verify it using the command arp-a. Now looking into the section for IPv4, we have the source IP, which is the IP of my system, and the destination IP, which is the IP of the HTTP server. Now examining the TCP section, we will see the source port is this, which is usually a dynamic port selected for the particular HTTP connection, and the destination port is 443, which is for HTTPS. Now if protocol was HTTP, then the destination port would have been 80. Then we look into the different columns here. We have the number of packets, time elapsed, and source IP, destination IP, the protocol, the length, that is number of bytes in each packet, then the extra information about the particular packet. We look into the different protocols we have here, which is TLS, Transport Layer Security, version 1.2, then TCP, Transmission Control Protocol, need to remove the filter so that I can see all the protocols here. Now QUIC, which is Quick UDP Internet Connection. Then I have DNS, which is Domain Name System. Then I have UDP, User Datagram Protocol. Those are the protocols that are used for this capture. Now I'll check on the case of capturing packets associated with HTTP. So I give the filter HTTP. So there is an HTTP request and response. Here we have the source and destination IP, the protocol, and we have already seen the format for HTTP request and response. Like the previous case, we have an Ethernet 2 section, IPv4 section, and TCP section. Since this is HTTP, we have information related to HTTP also. Now that will give extra information about contents like host, the connection, user agent, referrer accept and cookie fields. Now I'll go and check for the corresponding acknowledgement packet. Now that is the server TCP acknowledgement for receiving the GET request. I'm checking on HTTP response now. Similarly, when I check the section for HTTP, this is of the request. I need to click on that and check. So the contents will change, which are being the location, cache control, content type, server, cookie details, etc. Again, going back to the captured packets and checking for the corresponding acknowledgement. This will be the client TCP acknowledgement for receiving the HTTP response. Now I can filter out data based on packets coming or going to a particular IP address. For that, I need to enter ip.adder equal to the particular IP address. So the IP address I am selecting here is 142.250.194.132. Now this will have this IP address either at the source or the destination section. Now we'll look into the statistics option where we have options like flow graphs. We have already seen this. This is showing a TCP flow graph here. You can choose it based on the flow type we want. We'll also look at protocol hierarchy for this capture. So for each frame or Ethernet, you can expand it and see the details based on the protocols that come under them. We can also examine the same. That's all for now. Thank you for watching.